in order to figure out how many bacterial cells there would be after 10 hours of dividing in your leg, we need to start by figuring out how many generations there would be. So we would do one generation is every 4 minutes. We know that there is 60 minutes in 1 hour. Our units of minutes cancel out and that unit disappears. And then we know that they're going to divide for 10 hours. So now our unit of hours disappeared and we're left with a unit of generations. And we just multiply 1 times 60 times 10. And then we would divide that number by 4 times 1, which is 4. So 1 times 60 times 10 gives us 600 divided by 4 tells us that there's been 150 generations. So now that we know the number of generations, we need to look for a mathematical equation that we can use to solve for this, because our spreadsheet doesn't go to 150 generations, it only goes to 31. But if we notice, when we have 0 generations, 2 to the 0th equals 1, and that matches. 2 to the 1st equals 2. Well, that's what we get for our first generation. 2 to the 2nd equals 4. That's what we get for our second generation. 2 to the 4th equals 16. That's what we get for our fourth generation. So we can just set our generation number as our exponent. So when we do this equation, our generation number, which in this case is 150, becomes our exponent. And since we started with 8 cells, we just multiply by 8. So we can just do 8 times 2 to the 150th power because we have 150 generations. So 8 times 2 to the 150th power gives us 1.14 times 10 to the 46th power, which means that we would move this decimal place here to the right 46 times, and we'd end up with a number with 44 zeros at the end of it. It's an absolutely massive number. To maybe try and show you just how massive this number is, the average bacteria has a mass of 1 times 10 to the negative 12 grams, which means 1 times 10 to the negative 15th kilograms. If we multiply this number by that, so times 1 times 10 to the negative 15th power, we now have 1.14 times 10 to the 31st kilograms. That's the mass of those cells. That is 6 times the mass of the sun. So obviously in our body, when we get bacterial cells, the growth doesn't remain exponential. If it did, after not even half of a day, you would have the mass of 6 times the sun of bacterial cells, and that's not possible. So this growth is limited by resources. Bacteria need sugar to survive. They need other resources. They're competing for space. So that growth does not stay exponential. The cells are going to start dying. The cells that don't get enough energy won't reproduce at all. So in real life, growth doesn't stay exponential because, as you can see, it would become impossible to maintain that mass of life on Earth. Thanks for watching. Hopefully this helped you answer the last couple of questions of this assignment.